now, this is guided practice 15, section 4.5 on trig derivatives. So in the lecture, we worked on finding the derivative of the 6 trig functions. So in the practice problems, we're going to work on integrating those in with our other rules. So this first one, we have 4x multiplying sine x. So I'm going to make this my function 1, and sine of x will be my function 2. So I said function 1 is 4x, and its derivative is 4. Function 2 is sine x. And in the lecture, we established that the derivative of sine x is cosine x. And then we use our product rule to put it all together. So this is 4 sine x plus 4x cosine x. And I can just leave that. If you really want to factor out the 4, you can. But there's no like terms here, so I'm just going to leave it like that. In number 2, notice that in the first one, I have a number times sine x, and in the second one, I have a function times cosine x. So in the first term, I don't have to use product rule here because a number times a function, we can leave the number, take the derivative of the function. But because I've got the x, I'm going to have to use product rule on this one. So 5x will be my function 1, and cosine will be my function 2. So function 1 will be the 5x, and its derivative is 5. Function 2 is the cosine of x, and its derivative is negative sine x. So when we put all this together, the first term we leave the 12, and the derivative of sine is cosine x. Plus, for the second piece, we have our product rule, 5 times cosine x plus negative 5x sine x. And then you actually do get two like terms here. So this is 17 cosine x minus 5x sine x. And that's my final answer. Again, no like terms to combine at this point. So we leave it like that. Number 3 looks like it should be a quick and easy integral. Derivative. And this can be rewritten as the cosine of x squared. Okay, those are equivalent, exactly the same. Mathematicians just get lazy and we don't want to write the parentheses, so we move the 2 to be above the s. But because we have the parentheses and the square, we have a chain rule. The cosine is my inside function, and the 2 on the outside is my outside function. So in order to take the derivative, I need to bring down the 2, leave the cosine of x. Its new exponent is 1. And then we multiply by the derivative of what's inside. And what's inside is cosine, so its derivative is negative sine x. And we just get negative 2 cosine x sine x. And that's it. Okay, so a lot less simplifying here. Number 4. Now this one, I'm going to rewrite with the power again. So this is sine of 3x plus 2, and the 3 goes all the way on the outside. And so this gives me 3 nested functions. So I have the 3 on the outside. I have the 3x plus 2, which is on the very inside. And that means that sine is kind of a middle function. So when we have multiple functions that are nested together like this, with chain rule, we start on the outside and we work our way inside. But we only differentiate one thing at a time. So that means when I go to find my derivative, I'm going to handle the 3 first. So I'm going to bring down the 3. I leave everything on the inside alone. Okay, decrease the exponent by 1. So that's the derivative of the outside part. Times the derivative of the inside part. So the next thing that's inside would be the sine. So the derivative of sine is cosine. I'll leave everything on the inside. And then multiply by the derivative of the very inside. So times 3. Notice your function kind of gets smaller as you go because you're going further and further inside. So if we think about how it matches up, this whole piece is the derivative of the 3. This is the derivative of the sine. Oh, whoops. Wrong color. This is the derivative of sine, and this is the derivative of the inside function. Notice that your trig functions never change their argument. The argument of the trig function, meaning what comes after the trig function, should always, always, always be the same. You can clean this up if you like by putting the 3's together. So this is 9 times sine squared of 3x plus 2 times the cosine of 3x plus 2. Final answer. And then lastly, you have a quotient. So in this case, I would rewrite this again as the cosine of x cubed over x plus 2. Not everything is to the same power, so you're going to have a top and a bottom. So my top is the cosine x cubed. To find its derivative, we use chain rule. So bring down your 3, keep your cosine x, new exponent is 2, times derivative of cosine is negative sine. For the bottom, you have x plus 2, and its derivative is 1. So when we put this all together, you have f prime of x equals top prime bottom, so negative 3 sine x cosine squared x times x plus 2 minus these two, so cosine cubed x all over the x plus 2 squared. Okay, again, this x squared and this x squared cannot be canceled because there's not one over here. Okay, so it's tempting, but don't do it. Oh, sorry, I jumped. All right. The other thing you could do, you could factor out cosine squared, but it actually looks messier than I think it looks right now. So I'm going to leave it just like this. So my answer is that one.